Okay, this is a very important concept. Exponentials. There are various questions which can be formed on exponentials as a class as far as remainder theorem is concerned. So we need to be very clear about this concept. So, okay, these are certain identities that you need to remember. So if you have a question of the form a raised per n plus b raised per n, this will be divisible by a plus b if n is odd. Now, how do you remember this? Just substitute n as 1. N is equal to 1. Obviously, 1 is an odd number. It is not even. So, if I put n is equal to 1, what do I get here? I get a plus b. Obviously, it is divisible by a plus b. So, you can just see that, okay, if just remember it this way, that if n equal to 1 gives you this thing to be divisible by a plus b, it will be true for all odd numbers. This is just to, for you to remember. This is, you cannot obviously deduce this by just substituting one number in n, but this is for your understanding and for you to remember. Now similarly, if you have a number of the form a raised per n minus b raised per n, this number will be divisible by a plus b if n is even. Now again, what you do is you put n equal to, see, if you put n equal to 1, what will you get? If n is equal to 1, I get a minus b. So that is divisible by a minus b. We'll come to that later. Now let me put n equal to 2. I will get a square minus b square, which is equal to a plus b into a minus b. So you can see this is divisible by a plus b. So if for n equal to 2, 2 is an even number, this whole thing becomes divisible by a plus b. It implies that whenever I have an identity of the form a raised per n minus b raised per n and n is even, it will be divisible by a plus b. Now here we say if a raised per n minus b raised per n is the form, it is always divisible by a minus b, whether a is even or odd. Again, you can check this very simply. If I put n is equal to 1, you get a minus b directly. Obviously that is divisible by a minus b. And if I put n is equal to 2, I get again a square minus b square, which is of the form a plus b into a minus b, again divisible by a minus b. So in any condition, a raised per n minus b raised per n will be divisible by a minus b. Okay, now take some few examples. If I have 2 raised per 101 plus 3 raised per 101, this will be divisible by 5. Why? This is of the form a raised per n plus b raised per n, where n is odd. So it will be divisible by a plus b. So which is divisible by 2 plus 3 is equal to 5. Similarly, if I have 17 raised per 44 minus 16 raised per 44. Now in this case, this is of the form a raised per n minus b raised per n, where n is even. So in this case, it will be divisible by a plus b, that is 17 plus 16, which is equal to 33. Now if I have 8 raised per 6 minus 5 raised per 6, so it will always be divisible by, like we said, a minus b. It will be divisible by 8 minus 5, 3. And at the same time, it will be divisible by a plus b also, because it is of this form, if you see here, where n is even. So it will also be divisible by a plus 5, which is equal to 13. Okay, so this is another concept which is used very frequently in solving questions. You'll see this when we take examples later. So if I have any number of the form ax plus b raised per n, and I'm trying to find out the remainder when this whole thing is divided by a. Now for any equation, let's take a simple example first. Let us say I have a plus b raised per 2. What will I have? I'll have a square plus b square plus 2ab. So basically I have a term which is, the only power of this. Then I have a term which is a power of both these numbers, and then I have a term which has a power of only b. Now this is true for any power of, whenever I have this form, there will be some term which will be only a power of this a raised per n, plus there will be some terms which will be, let us say, a raised by n minus 1 b, some factor here, plus some factor here, a raised by n minus 2 b raised by 2. We are not very concerned with what these numbers are, but they will have a multiplication of both a and b, plus there will be a term which will be b raised per n. Okay, so what does this tell us? This tells us that whenever we have a number of this form, ax plus b raised per n, and we are trying to divide it by a, if I will expand it, I will get lots of terms like this. but all of them will have a factor of a except one term, which is what? This, b raised power n. So when I'm trying to find the remainder of ax plus b raised power n when divided by a, the only term which will not have a as a factor will be b raised power n. So the remainder will be either b raised power n, or if that is greater than a, it will be we find the remainder when b raised power n is divided by a. Now as a special case, let me put b as 1. Again it will be the same thing. If I expand this, all the terms will have a in it except one term, which is this plus 1. So the remainder of this thing will be 1 raised per n, which is equal to 1. Okay. Now, so let us try to use this concept here. So I have this question, 8 raised per 343 divided by 7. So what will be the answer? So I can write 8 as 7 plus 1, because 7 is the number here, raised per 343. Again, the remainder in this case will be 1 raised per 343, which is equal to 1. Let's take another question, 50 raised per 25, and again I'm trying to find the remainder with 7. Obviously 7 is not necessary, you can have any number here. So now you need to apply a little more thought into it. So 7 square is 49. So this will be written as 49 plus 1 raised per 25. Again the remainder is 1. Now if I have 48 raised per 36. Now in this case I will be writing it as 49 minus 1 raised per 36. Now if you see, we were discussing plus 1 cases here, so let me write it as 49 plus minus 1 like this, raised per 36. So the remainder will be minus 1 raised per 36, which is equal to 1. Okay, so this is important here. So see, in all these cases, what am I trying to do? I'm trying to get this whatever number I have as a factor of plus 1, because whenever I have 1, I will get the remainder as 1 directly. Okay, now in case, now let's take another example here. If I had 48 raised per 35 and again divided by 7, now this will be 49 minus 1 raised per 35, remainder will be minus 1 raised per 35, right? So the remainder comes out to be minus 1. Now as we know, obviously remainder cannot be minus 1, but we learned previously that whenever we have a minus 1 concept, the remainder will be the divisor 7 minus 1, which is equal to 6. So the basic concept in these questions is that whatever number is given to you in exponential form, you try to get that as plus 1 or minus 1, and then it will be very, very simple for you to find the answer. In certain cases you might have to do it, it might be a two-step process. Like here we are doing it in one step, directly we got 7 plus 1. But in case, let us say, if we had a question of 9 raised per something 101 and you were dividing it by 7, in this case you might have to write it as 7 plus 2 raised per 101, then the remainder will be 2 raised per 101 with 7, and then you will have to write this as 8 minus 1 or something like that. So we'll see these questions later, but this is what basically the concept is, that you try to find the number, the exponential that is given to you as a power of as a plus 1 or a minus 1 factor, so that you can solve the question easily.